In this video, we're going to talk about solving right triangles, and the two main objectives for this video are finding a side on a right triangle using trigonometry and finding an angle on a right triangle using trigonometry. So let's get started. Now, before we get to the actual portion, let's review trigonometry here. And so the best thing to do is to review the sine of theta, the cosine of theta, and the tangent of theta with respect to the right triangle. So we have this right triangle here, which shows the angle theta, the side opposite of theta, the side adjacent to theta, and the hypotenuse, which is the longest side of the right triangle. And as a refresher, sine of theta is equal to that opposite side over the hypotenuse. Likewise, cosine is the adjacent side over the hypotenuse, and tangent is the opposite over the adjacent. And if you look at my previous videos, which talk about right triangle trigonometry parts 1 and 2, you'll get a better understanding of what the trigonometric ratios are. But let's get started. In this first example, we're asked to find the missing side of the right triangle below. So we have a side of 15, x, and there's no hypotenuse, which is okay. That's totally fine, right? So we have the angle. That's probably the most important thing here. The angle's location, or the 41 degrees, right? So this 41 degrees will actually guide us into starting our problem. And with respect to the 41 degrees, 15 is the opposite side and x is the adjacent side. So the question is, which trig ratio uses opposite and adjacent? And so the only one that does that is the tangent ratio. So tangent of 41 degrees, which is our theta, is equal to 15, so the opposite, over the adjacent x. Now, from here on, we're just going to use algebra to solve for x. So the first thing I would do is multiply x to both sides and cross out the x's over here. So that's gone. That's gone. So now we get x tan 41 degrees equals 15. And all you have to do now is get x by itself, so divide tangent of 41 degrees to both sides. Now, if you're doing this, well, I was going to say if you're going to use it with a calculator, but obviously you need one, right? So when you're using the calculator, make sure you check your calculator's mode. So check calculator mode, because you need to make sure your mode is in degrees. To be in degrees. So if your mode is wrong and it's saying radians, please change that, because if you don't change it to degrees mode, your answer will be wrong from what I get. So once I do the work and I plug it into a calculator, x gives me 17.3. Now, preferably when I'm doing these and it's not an exact value or like a nice whole number, I prefer rounding to one decimal place. So here it is, 17.3. Let's try the next problem. For example 2, we have the angle of 23 degrees. So this will be our driving force of the problem, like the previous one, 23 degrees. And with respect to with respect to 23, x is the opposite, the adjacent side, and 30 is the hypotenuse. And there's only one trig ratio that uses adjacent and hypotenuse, and that is the cosine. So cosine of 23 degrees is equal to x over 30. And just like the previous problem, we're going to get our x by itself. And in this case, we're going to multiply by 30. So I'll do times 30 right here. And that gives me x equals whatever 30 cosine 23 degrees is on the calculator, which is 27.6. Oops, that's a mistake. 27.6. All right, moving on to the next part. So we just did 2 examples on missing sides of triangles. Now let's see how we can do it with missing angles now. But before we do that, I think it's a good time to introduce inverse trig functions to you. So when you're missing an angle theta on a right triangle, you can use inverse trig functions to find out what that missing angle is. So for instance, if sine of theta equals x, then you would then say theta is equal to the sine inverse of x. So this sine -1, this -1 is not an exponent, or it's not a reciprocal. It's going to be the inverse. Oops, okay, inverse. And same thing, cosine theta equals x, then theta equals inverse cosine of x. And then tangent theta equals x, theta equals inverse tangent of x. And in this example right here, we're going to find that missing angle using the theta as our driving force here. So for the most part, when we're dealing with triangles or right triangles that have 2 sides given to us and an angle, we can find the missing angle, or we can find the missing side, depending on what variable is given to you, right? And in another video, I'll talk about how to solve a full right triangle and find all the missing sides and angles in one of them. But here, we have 2 sides, and with respect to theta, that 17 is going to be the opposite, and that 18 is going to be the adjacent. And there's no need for the hypotenuse here. So what we're going to do is, since it's opposite over adjacent, I'm going to use the inverse tangent. So theta equals inverse tangent of 17 over 18. And if I plugged it into my calculator, I would get theta is equal to 43.4 degrees. So likewise with side lengths, I like to put my degrees in 1 decimal place as well. In this example right here, we have the side lengths of 29 and 52 and angle theta. So I'm going to circle theta again. And with respect to theta, 29 is the adjacent. Oh, it's the opposite. My bad. I'm glad I caught that. The opposite. And 52 is the hypotenuse. And so this is going to be opposite of hypotenuse. So I'll use theta equals inverse sine of 29 over 52. And if I plug it into the calculator, I get theta equals 33.9 degrees. Now, hopefully this video gives you a good introduction of how to find missing sides or angles in a right triangle. Please leave any comments below, and hit and like that subscribe button. All right, awesome.